Section 1.5 is titled Proofs That Are Not Valid. Okay, take a look at this. So on the left we have a square that is 8 by 8, which is 64 units squared. But look what happens. When we move the shapes over, we get a rectangle that is 5 by 13, which is 65 units squared. How does this work? It shouldn't. Think about it. See if you can figure out what's going on there. So sometimes proofs are not valid. So cutting out one shape and pasting it to another, maybe there's some error there. It's not quite right. Take a look at example 1. James says he can prove that 3 equals 4. Here's his proof. Let A, B, C be numbers. Suppose A plus B equals C. This can be written then as 4A minus 3A plus 4B minus 3B is equal to 4C minus 3C. Okay, that's fine. He can do that. That's just an equivalent expression. If we put all of the 3's on one side and all of the 4's on the other side of the equal sign, we can write 4A plus 4B minus 4C equals 3A plus 3B minus 3C. Okay, yes, he can do that as well. Then we can factor 4 out of the left-hand side and 3 out of the right-hand side. So we get 4 times A plus B minus C is equal to 3 times A plus B minus C. Now we divide by A plus B minus C on both sides, and we get 4 equals 3. What's wrong with this proof? Why is it invalid? Well, we absolutely know that 4 does not equal 3, so there's definitely something wrong with this proof. One thing that we can never do in math is divide by 0. Our calculator tells us so. And that's exactly what James did. So take a look at this statement right here. Suppose A plus B equals C. We can rewrite it as A plus B minus C is equal to 0. And if we go down, you can see that he was dividing by A plus B minus C on both sides. So he was dividing by 0. That's why this proof is invalid. Example 2. Brandon tried to show that negative 5 equals 5. Here's his proof. He assumed that negative 5 equals 5. If we square both sides, you get negative 5 times negative 5 equals 5 times 5, so 25 is equal to 25, which is a true statement. That means our assumption must be correct. Why is Brandon's proof invalid? He's using circular reasoning. He's saying that because this is true, because this is true. It's a circle. One good example of this is a conversation between a parent and a child. The parent says, it's bedtime, go to bed. The kid asks, why? The parent says, because I said so. It's using the premise as the conclusion. It's circular reasoning. It's a great example. All right, take a look at the next example. Where is the error in the following proof? Travis is trying to prove that the following number trick always results in 5. Choose any number, add 3, double it, add 4, divide by 2, take away the number you started with. All right, so he made a 2-column proof. It was proof, justification, good, n. So we choose any number, good. And then we add 3, so we added 3, very good. Doubled it, multiplied by 2, looks good. Added 4, divided by 2, and then subtracted the number we started with, n. But he ended up with n plus 5. So we know that there's something wrong with his proof. Because if you actually try this, it does work. Where's his error? Okay, so he was good to multiply by 2. This makes sense. Then he added 4. Well, that works because 6 plus 4 is 10. Divided by 2. Oh, he forgot to divide by 2 here. So that's his error. It was just a math error. That's why his proof is invalid. So here's some notes for you to either write down or memorize. Some definitions. An invalid proof is a proof that contains an error in reasoning or that contains invalid assumptions. Circular reasoning is an argument that is incorrect because it makes use of the conclusion to be proved And deductive reasoning is using known facts or assumptions to draw a conclusion. So please try in your textbook, pages 42 to 44, numbers 1, 2, 3, 5, and 7.